This lesson is on 4.5, which is patterns in linear equations and graphs. So you now know how to find the slope of a line by looking at its graph. You can also find the slope of a line by looking at its equation, and that's what we're going to focus on in this case. So we have two new vocab words. So you already know from a graph, we're going to figure out. You can also determine the x-intercept and y-intercept by looking at a graph. So we know we can find the slope. Now we can do the intercepts. Now first, we have to know what is the x-intercept. Well, the x-intercept is the coordinate of the point where the line crosses at the x-axis. Or you can also think of it as where the y-coordinate is 0. So in this case, we have this point is where it's crossing the x-axis. So this is our x-intercept. And in this case, it would be at not 1 or not 2, it's in between, so at 1.5. Our y-intercept is the y-coordinate of the point where the line crosses the y-axis when the x-axis is 0. So in this case, along here, x is 0, we cross here. So here is our y-intercept, which is equal to -3. So we're going to use these going forward to help us use these linear equations to create a graph. So example 1 is a hockey player receives 2 minutes in the penalty box for each minor penalty. A player already has 4 minutes in the minor penalties. So we're going to try to graph this equation here, y equals 2x plus 4, where x is representing the number of additional minor penalties he has received. He already had 4, so he has 0, 1, 2, 3, 4, and so on. And we're going to use this to find the slope and the y-intercept. So we're going to start with a table, and we're going to plug in, you can do any values, but I plugged in what if x was equal to -2, 0, and 2. So we're going to plug these into here and solve for y. So if x equals -2, we have 2 times -2 is -4, plus 4, our y would be 0. If we had 0 more penalties, we would stick with the only 4 minutes of penalty time. And then what if we had 2 more penalties? Well, then we'd go up to 8. So now we have a few points we can graph to then create the slope, or find the slope eventually. So in this case, let's go at -2, 0, here's our first point, at 0, 4, and then at 2, all the way up to 8, up here. So then we can connect them with a line. All right. And now that we have our points, we can look at, well, what's our rise over run? Let's focus on, you could do either of these 2 points. So I'm going to pick here. So our rise, so I'm going to assume I'm going from this point to this point. Our rise is going to be 4 from here to here. And our run is going to be 2. They're both positive because it's going to the right and up. So in this case, our slope is equal to the rise over the run, 4 divided by 2, which equals 2. And then they also want us to make sure, so we graphed it, we found the slope, but what's the y-intercept? Remember, our definition of the y-intercept is the value at which it crosses the y axis, so its value. So in this case, it crosses at 4. So our y-intercept equals 4. So let's look at a second example. So another type you might get is example 2 is graph this value, find the slope, the x-intercept, and the y-intercept. So in this case we have a fraction here, but that's okay because this is showing us our rise over our run, which you'll notice later. So same idea, let's plug in for x, 3 values we'll try. So when x equals -4, we're going to have y equals -3/4 times -4 minus 3. So the way I do these on my calculator is, first off, I never use the negative sign. I know the rules. So 3 times 4 on the top divided by 4. I didn't need a calculator. This is going to be 3 minus 3, which y equals 0. So when x equals -4, y is going to equal 0. Now for the next one, I can plug 0 in for x, which I know this will cancel out, so just leave me with -3. And then the last one, I'm going to plug in 4 for x. So y equals -3 over 4 times 4 minus 3. Well, in this case, -3 times 4 is -12 divided by 4. These are just canceling out. -3 minus 3, which equals -6. Now I can plot these. So I'll start with -4, 0. Then 0, -3, and then 4, -6. So in this case, hopefully you'll be able to recognize that we have a negative slope. So what else are they asking us to find? Graph the points, we did them, and connect them with a line. We did that. We can also find our slope, which in this case is, this is going to be moving 4 for our run, -3 for our rise. So our slope equals -3 over 4. Look at this. If we go back to our equation, this value in front of x is what represents the slope. And then you can see here, what is our y-intercept? Our y-intercept is -3. This here, this number, represents our y-intercept. And this equals our slope. That's just something to keep in mind, because you're going to notice as you see more and more of these, you should be able to have a better understanding of what this graph and slope is going to look like before you even plot the points and draw it. So for the third example, they give you two equations, or two plots. Y equals 2x minus 1, and y equals 2x plus 3. And they want you to plot it on the same grid, then find the slope of each line. So I'm going to draw this here, and then do some work to find this. So let's make a table for x and y. Let's focus on equation 1 first. So when x equals, let's say, 0, 1, and 2, you can pick any 3. 3 is usually helpful, because then if you notice, if you did only 2 and you made a mistake on one, your line will be wrong. If you do 3 and notice that they're not going to connect, you know you made a mistake and can go back. So when x equals 0, y equals -1. When x equals 1, that would be 2 minus 1. This will be 1. When x equals 2, it's going to be 4 minus 1, which is going to be 3. So we could go ahead and plot that in red. So 0, -1 down here, 1, 1, and then 2 and 3. Okay, and then the second one, we'll make another little table to help us with the points for x and y. So let's also do that, 0, 1, and 2. So when x equals 0, y is going to equal 3. When x equals 1, y will equal 5. And when x equals 2, y is going to equal 7. So now on the same graph, let's do at 0, have it up there at 3. At 1, we have it at 5. And actually the next one, 2, we're going to have at 7 will be up here, which is a little off my page, but I can still use it to help me connect them. So what I notice immediately about these two is that they look parallel to me. Parallel meaning they have the same slope. So parallel lines, maybe you add this to your vocab, are lines that have the same slope. Now we could calculate the rise over the run by taking it between 2 points, right? We can go over 1, up 2. So our rise is 2, our run is 1, to give us a slope equal to 2 over 1, which equals 2. Same thing here. Or we could also go back and look at the equation. Remember we said in the previous problem that our slope here is the coefficient of x. Slope here. So we knew, or could have known, that these two lines were parallel before even beginning, because they have the same coefficient for x, which means they have the same slope. And lastly, I want you to try a few on your own. So I want you to graph each equation and find the slope, the x-intercept, and the y-intercept. For y equals 3x minus 6, and b, y equals -1/2 x plus 4. And then I also want you to do a little reflection question and answer, what pattern do you notice between graphs and equations related to the coefficient of x? But you can also relate it to other things. What patterns are you seeing? Look for when things are positive and negative, or positive and negative slopes. See where that comes from. So that's all for this lesson, and that ends our chapter 4.